So in this class, we are going to discuss the mechanisms of nucleophilic substitution reactions of alkyl halides. So in the previous class itself, we have studied how the nucleophilic substitution reactions takes place, the reason for nucleophilic substitution, and some of the examples under nucleophilic substitutions. So in this concept, we will take one example of nucleophilic substitution reaction and we'll discuss that reaction detailedly with mechanism. So mechanism is nothing but how that reaction takes place in step-by-step manner. Right. Generally, a nucleophilic substitution reaction of alkyl halide may be of two types. One is SN1 reaction, the other one is SN2 reaction. Very, very, very important. Right. The first one, mechanism of SN1 reaction. So let us take a simple example of nucleophilic substitution, that is reaction with aqueous base. Reaction with aqueous base. So we know that when alkyl halide is treated with an aqueous base, we'll get alcohol. In place of halogen, we'll replace OH. But what is the difference between SN1 and SN2 means the type of alkyl halide which reacts with aqueous base. That is difference here. So one of the classification we already studied is the alkyl halides are of three types, that is primary alkyl halide, secondary alkyl halide and tertiary alkyl halide. So in SN1 reaction, only tertiary alkyl halides participate in nucleophilic substitution reaction in SN1 reaction. Right. So what is this SN1 means? 1 is nothing but unimolecular. N means nucleophilic. S means substitution. Unimolecular means one molecule, a single molecule. So what is the meaning for that? So that can be known while discussing the mechanism here. So this is a reaction under SN1 reaction. Example for SN1 reaction. Then how this reaction takes place? What is the mechanism involved in this reaction? Means the mechanism involves two steps. In the first step, this alkyl halide undergoes slow ionization. Ionization means dissociating into ions. So that ionization takes place very, very, very slowly. So that after ionization, so already I have given the idea about how that ionization takes place in case of alkyl halide. This halogen ionized as anion and this carbon will be ionized as cation. A carbocation will be formed. This is carbocation. An intermediate carbocation is formed. And why we are mentioning unimolecular here means any reaction, if you want to know the velocity of that particular reaction or rate of that reaction, so we can determine the rate of any reaction if the reaction is slow. So as this step is slow step, we can determine the rate in this step also, in this step only. Okay, so as the rate is predicted or it is based on step 1 only, in this step 1 the rate is depending on the concentration of only alkyl halide but not on this base. So far I did not introduce the base in this step, so only I have introduced the alkyl halide, so no base here. So that means the rate is depending on only concentration of alkyl halide. So that order will be the power of this concentration concentration. The power of this concentration is 1 here. So that order is equal to 1. And as the rate is depending on only alkyl halide, it is unimolecular. This is first step. In the second step, The carbocation formed in the first step is planar, as it is carbocation. The shape, the structure of carbocation is planar. So plane is nothing but like this or in this manner. Hence the base OH minus. So if this is the plane of the molecule or the carbocation, the base can attack from front side or the base can attack from back side. Front side, back side. So there are two chances of forming the products. One is totally inversion of configuration, that is in this manner. The resultant product will have the configuration in the inverse manner. That means OH is on left side, or the OH will attack from front side where the configuration retains same. See here, the bromine is present on right side. Here the OH is present on right side. The retention of same configuration. The another chance, if it attacks from back side, this is the structure. So this is inversion of configuration. So both inversion and retention is taking place. Inversion and retention is taking place. Hence, it is not racemic mixture is also formed, and the configuration is called racemization. The configuration is called racemization takes place. So this is the stereochemistry of SN1 reaction. Finally, the order of reactivity of alkyl halide is tertiary is greater than, secondary is greater than, primary is greater than methyl halide. That means tertiary alkyl halides immediately undergoes SN1 reaction. So why SN1 reaction only? That I will give you the reason for this after completing the mechanism of SN2 reaction. So this is about the mechanism of SN1 reaction. I hope you understood this concept.